Just on the concluded resolution of forces, and this is one of the questions you will see in your UTMA past question. It is JAM 2007 question 42. Now you can see the diagram here. These are several forces acting on particle P. We'll read the question just to give you an overview of what the question says before I read it. So what are the forces? You have one acting on it, 3√3 Newton, 10 Newton, 3 Newton, and 6 Newton. So let's look at what the question says. The question says the figure above show 4 forces. What are the 4 forces? 3 Newton, 10 Newton, 3√3 Newton, and 6 Newton acting on particle P, as you can see. Now, the resultant of the 4 forces is option A, 10√3 Newton, option B, 10 Newton, option C, 5√3 Newton, sorry about that, and option D, you have 5 Newton. Now, one thing I've told you under resolution, which you need to know as a student, is please don't stress yourself. All the old things that we explained earlier, we want to make use of them and see how easy resolution of forces. No matter how, if there are 20 forces, it is the same pattern. So what do you do, my student? The first thing you do is to draw a simple chart, a table. Put here, this is for the force. Remember what we want to achieve is that to put all this force, number 1, in a vertical component. The second part is to put all the force in horizontal component. These are the 2 things. Now, don't forget the nature of your force. We have vertical, horizontal, and what? Oblique. And don't forget your signs also. If your vertical force, if the arrow is pointing up, positive, pointing down, negative. Don't forget for horizontal, if it's towards the right, positive, towards the left is negative. So let's make use of it here. Now, I'm going to be calling the first one after the other. We will identify them, then we'll look at what their values will be. So the first, let's go in this direction. So we are starting with what? 3√3. Sorry, 3√3, yeah. For 3√3 in Newton, what do we have for 3√3? This 3√3 Newton, the first question is, this guy, is he a vertical force, horizontal force, or oblique? As we can see, this guy is pointing upward and it's straight. It is a vertical force. What do I call it? Vertical. Once I know it is vertical, the first thing I must attend to is to go straight to the horizontal. The horizontal of this guy is equals to 0 because I've called it what? Vertical. So what will now be the vertical component? The vertical component of this guy is its value itself, the way it is. What is it? 3√3. Case close. Now, the next thing to do is this one that have value. This one does not have value. So this one that have value, we need to look about the sign convention. Because we are dealing with vertical. This force, is it pointing up or is pointing down? Pointing up, correct. So this guy is going to be what? Positive. Perfect. And after that, I move to the next one here. What is the next one? 10. This 10, what kind of force is 10? Is it vertical, horizontal, or oblique? Without wasting time, this guy is what? Oblique. Now, for every oblique force, remember we said what we are looking for is angle to the horizontal. This is the horizontal we are talking about. What angle does this 10 make with the horizontal? 30. Don't stress it because it's an oblique force and it makes 30 degrees with the horizontal. What do? Just say horizontal is what? Vertical is sine. That will be 10 sine 30. And this is going to be what? 10 cos 30. Case close. It is an oblique force. Angle is 30 degrees to horizontal. Straight away, vertical is the value, sine 30. Horizontal is that value, cos 30. Case close. Now, the next thing we now need to talk about is the sine, because both of them have value. In terms of sine, what do we have? For vertical, what is our main aim? Pointing up. Is this guy pointing up or down? It's pointing up. Positive. Correct. For horizontal, what we talk about is it pointing right or is pointing left? So let's see, is it pointing right or left? Right. Positive. Confirm. And don't forget, in this case now, we have to solve these 2 values. Sine 30 is what? Half. So 10 multiplied by half will give us what? 5. Cos 30 is 10 times cos 30 is √3 over 2. You know this is general, I don't use calculator, so you have to be either 2 here, 1, 2 here is what? 5. So what do we call this one? 5√3. So the value of this one is 5√3. The next one we are going, this is the first one. This is the second one. The next one we are going now is 3 Newton. 3 in Newton. Newton is here. What kind of force is this 3? This 3 guy is what? Horizontal. What did I call it? Once I mention horizontal, my vertical is what? 0. No cause for alarm. But what will not be the horizontal? Horizontal is the value itself, 3. Then the next one is because the horizontal has value, we need to know the sign. What sign am I going to give to this? So in this case now, for this sign, is for horizontal. We say that right or what? Left. Where is arrow pointing? Right. Because it's pointing right, then this is going to be what? Positive. Clear? Good. Then the last one we are going to talk about, which is the last force, is 6. What kind of force is 6? 6 is also oblique. Why? It make an angle what with the horizontal? 60 degree with the horizontal. Without wasting time, what do? Because it's angle related to the horizontal, be what? 6 sine 60. And this is going to be what? 6 cos 60. Don't stress it. If that is the case, the next thing to talk about is the sign. If we are to come to vertical, we won't talk about vertical now. This guy in the vertical direction, is the arrow pointing up or the arrow is pointing down? It's pointing, if it is down, what do we say? Negative. Now we are done with that. In the case of horizontal, what do we talk about? Is it pointing towards the right or is pointing towards the left? In this case, pointing towards so this one will also be negative. Now, what is sine 60? Sine 60 is also root 3 over 2. So this is going to be minus 6 times root 3 over 2. So what do you get here? 2 here, 1. 2 here is what? So that will be minus 3 root 3. So this is minus 3 root 3. So what is cos 60? Cos 60 is half minus 6 times 1 over 2 here, 1. 2 here is 3. What do you have here? Minus. So the answer to this one is minus 3. So from here now, the next thing we're going to do is to now do what we call, remember, we have resolved all this force into a single vertical component. We call it summation what? Fy. We have resolved all this into a single horizontal component. We call it summation Fx. So let's add them together. This is plus root 3. This is minus root 3. So plus root 3 cancelled minus root 3. So what are we left with? This will be 5 plus 0. What will be left here is 5. If we come here again, this is minus 3, this is plus 3. This cancel this. So what are we left with? Is 0 plus 5 root 3. What will we have? 5 root 3. So what is our formula to get the resultant? The resultant says is the square root of summation of Fy squared plus summation of Fx squared. So my resultant is the square root. What is the Fy? Fy is what? 5 squared. This is it. What is Fx? Summation of what? 5 root 3 all squared. So my resultant equals to square root. What is 5 squared? 25. Plus, what is 5 root 3 all squared? This means 5 root 3 times 5 root 3. 5 times 5, 25. Root 3 times root 3, that is 3. 25 times 3, what would that give us? 75. This is going to be plus 75. So my resultant becomes 25 plus 75. What do you have? 100. So what would that be my resultant? What's square root of 100? 10 Newton. So if I resolve all these forces into a single component, the single components that the single resultant force is going to be 10. And from the option A, 10 root 3, 10, 5 root 3, and 5. What the answer? The answer is option B. That is 10 Newton. Is it clear? This is exactly how to solve question on resolution of forces.